Okay, so we're moving into some new material now, now we're going to be solving inequalities. So far, we've been solving different types of equations, linear equations, rational equations, radical equations, quadratic equations, and now we're looking at inequalities. So inequalities, we have the following. So let me just kind of read through this. So it says that inequalities involve two expressions separated by one of the inequality symbols, either less than, greater than, less than or equal to, or greater than or equal to. To solve an inequality means to find all values of the variable for which the statement is true. Because of the inequality, the solution set involves a range of answers where formal notation is needed. So a lot of times in mathematics, especially as further we go, we use interval notation. And so it says here that the definition of interval notation, let A and B be two real numbers where A is less than B. A closed interval denoted, so if I wanted the interval from A to B and it was closed, I would have bracket A comma B bracket. And this consists of all the real numbers, which A is less than or equal to X, which is less than or equal to B. So if it was an open interval, it's denoted with parentheses. So it would be parentheses A comma B parentheses. Consists of all real numbers X, which A is less than X, which is less than B. So sometimes that might be half open, half closed. So in this case, the half open or half closed intervals are, in this case, the first one where A is less than, X is less than or equal to B. The first piece is open, so I'm going to have a parentheses, A comma B bracket. So consisting of all real numbers X, which A is less than X, which is less than or equal to B. And if we were looking at A is less than or equal to X and less than B, then the first piece is closed. So closed, so bracket A comma B parentheses. Okay, so in each definition, A is called the left endpoint and B is called the right endpoint of the interval. If any interval is unbounded, the symbol infinity or negative infinity is used and always involves an open interval. Why is it an open interval when we use for infinity or negative infinity? It's because it doesn't stop at one particular number. It continues to increase or decrease. So you should be able to look at an interval notation or inequality notation and be able to find what the interval notation is and graph it. So for this piece here where it says the inequality, so this is actually set builder notation that they're using. And let me just tell you mathematically what that's saying. So that's curly bracket. This is talking about the set. Of the values of X. This vertical line, that means, or it says such that. And then it gives us directions or conditions about our variable X. And so in our first case, it says that, well, then A has to be less than X, which is less than B. So that's what that's saying. And so interval notation, they don't include A, don't include B. So it's parentheses A comma B, end of parentheses. To graph it, you're going to locate where A is on the number line, where B is on the number line, and we're going to shade everything in between. And we're going to use parentheses to say that we're not including A, and a parentheses on B, so we're not including. I tend to use parentheses and brackets when I'm doing the graph. You could use open circles or closed circles, but the parentheses brackets just kind of help us too with the same thing we would use for interval notation. This X such that A is less than or equal to X is less than or equal to B. We're including our left and right endpoints of our interval. So we're going to put brackets around the A and B. So only difference for the graph is that we have brackets instead on A and a bracket on B, and everything in between is shaded. Excuse me. Okay, so the next one, which is A is less than or equal to X is less than B. So we have a bracket A, comma, B, parentheses. So bracket on A, parentheses on B, shade everything in between. Where A is less than X is less than or equal to B, we would have parentheses A, comma, B, bracket. Same idea when we graph it. We're going to have a parentheses though around our A, a bracket on our B, shade everything in between. If X is greater than or equal to A, then we have a bracket on A. And then because it's everything greater than or equal to, we're going to infinity. So parentheses. So we're going to find A, we're going to put a bracket and shade everything to the right of A. If it was X is greater than A, then it's parentheses A to infinity. So same thing as above, but instead of the bracket, we're using a parentheses. If X is less than or equal to A, well, we're coming in, always going from smallest to largest. So we're coming in from negative infinity, and we're going to A, and we're including it because of the equal to piece. So in this case, we're shading everything to the left of A, and we're including A, so we have a bracket on that A piece. If X is strictly less than A, then we have the negative infinity to A parentheses. So parentheses, shade everything to the left. In the last case, it says X such that X is a real number. So it means that we're using every real number. So we're coming from negative infinity to positive infinity. We're shading everything on that number line. All real solutions. Okay, so let's look at the next example, and it says use interval notation to write the inequality using interval notation and graph the interval. Well, inequality notation, we have -2 is less than X is less than or equal to 0. So our left bound is -2, but we're not including. So we have a parentheses -2, comma 0, but we're including 0. So we have a bracket. And so shading the graph, we're going to locate -2 and 0 on the number line. We're going to have a parentheses around our -2 and a bracket on our 0, and we're shading everything in between. If X is strictly less than 3, this is where we're going from negative infinity to 3. So we're shading everything to the left of 3. We're not including 3, so we have a parentheses on 3. Opening to the left. And then we have 1.5 is less than x is less than 3. And so we're not including negative 1.5. So parentheses, negative 1.5, comma 3, parentheses. So we're shading everything in between negative 1.5 and 3, not including. And so we would have parentheses around our endpoints and shade everything in between. So in this case, now we're given the interval notation and we're asked to put this in inequality notation. And so here we have -4 and we have a bracket. So I know I'm including -4. That has to be less than or equal to x, which is less than or equal to 2 because of that bracket. I have the interval from 3/4 has a parenthesis, so it's not including 3/4 and going to infinity. So x has to be greater than 3/4. And then an interval not including 0 to 4, including 4. So we would write this as 0 is less than x is less than or equal to 4. So recall, if we square a real number, it's always going to give us back a positive number. It's always going to be greater than or equal to 0. If I square a negative, multiplying two negatives give me a positive. If I square a positive, multiplying two positives is a positive. So no matter what a is, it always is going to be bigger than or equal to 0 if we square it. So we have an addition property. Same thing with equations as with inequalities. If a is less than b or a is equal to b, we can add something to both sides and it remains true. So we could say then a plus c is still going to be less than b plus c. So adding c on both sides. If a is greater than b, same idea, doesn't matter which direction. If we add something to both sides, a plus c is going to be greater than b plus c. Okay, so next piece is a little bit of exploration. And it says true or false, is 3 less than 5? Well, yeah, 3 is smaller than 5. And if you can look at the number line, whatever falls to the left of a number is the smaller one. And so this is true. So now multiply each side of the inequality by 2. Do you agree that this is a true statement? Well, if I multiply 3 by 2, I get 6 is less than, and if I multiply 5 by 2, I get 10. So 6 is less than 10. That's still true. So multiplying by positive 2 continues to make it a true statement on both the left and the right. So the problem next is, again, true or false, is 3 less than 5? We asked still, 3 is less than 5, that's still true. But now if we multiply the inequality by -2, would this become a real, still a true statement? So if I multiply my, where did it go? 3 by -2, I would get -6 is less than 5 times the -2, that's going to give me a -10. So notice that this is not true anymore. -10 is smaller than -6. So this is a false statement. So that leads us to where we have to be careful when we're dealing with inequalities. If we multiply by a negative or divide by a negative, we have to worry about the inequality signs. Okay, so we have the multiplication properties for inequalities for real numbers a, b, and c. If a is less than b and c is a positive number, then it doesn't affect the inequality. It's still going to be a times c is less than b times c. If a is less than b and c is a negative number, c is less than 0, then it's going to flip my inequality. So this is now going to be AC has to be greater than BC. If A is greater than B and C is greater than 0, doesn't matter that this is greater instead of less than, but we're multiplying by a positive. It's not going to affect my sign of my inequality, so this is still greater than. Where if A is greater than B and we're multiplying by a negative number because C is less than 0, then that's going to flip my inequality sign here, and that's now going to become AC is less than BC. So if we multiply or divide by a negative number, then we're flipping our signs. Flip the inequality sign. So same sort of idea. We got to be worried about when we're looking at reciprocals. I know that if A is greater than 0, if I look at 1 over A, well, that's still going to be greater than 0. If A is less than 0, so if I put 1 over a negative number, that's still going to be less than 0. But if B is greater than A, which is greater than 0, then if we look at the reciprocal of the two, 1 over A is going to be less than 1 over B. And if A is less than B is less than 0, if we have 1 over B, then 1 over B is less than 1 over A, which is going to be less than 0. Okay, so basically, if we take the reciprocal, it's going to change the sign of our inequality. And so kind of let's just think about this really quickly. So let's say we had 2, we know is less than 4. If I took the reciprocal of 2, though, that's 1/2, right? Reciprocal of 4, that's 1/4. If I was compare 1/2 to 1/4, 1/2 now is bigger than our 1/4. That flips the sign of our inequality, taking the reciprocal. Okay. So we're solving inequalities. It really depends on what type of inequality that you're looking at. Right now, we're looking at a linear inequality. So how we solve linear inequalities is very similar to how we solve linear equations. We just got to be careful when we multiply or divide by a negative. So when we had linear equations, the first thing that we wanted to do was simplify both sides. But if you look at this inequality, x plus 3, which is less than 3x minus 7, that's already simplified. So now we want to isolate our variables and get the constants on the other side. So we could subtract x on both sides. So if we subtracted x on both sides, x minus x is 0. We have 3 is less than 3x minus x is 2x minus 7. So let's add 7 to both sides of our equation to get the x term by itself. So if we do that, we get now 10 is less than 2x. I'm dividing both sides by 2. So 10 divided by 2 is 5 is less than x. It's really important that you rewrite these inequalities so that the variables on the left, I think it makes it a lot easier to see and less room for error. So this is the same thing as saying x has to be bigger than, greater than 5. And I solved this without even looking at this. It wanted write our solution, set an interval or set interval notation, set builder notation, then graph the solution. So here, set builder notation, remember, was that parentheses, the x, that vertical bar such that x is greater than 5. Interval notation, it's anything bigger than 5. So we're starting at 5, but there's a parentheses around that left bound going to infinity. And then graphing it, we're starting at 5, and we're shading everything to the right of it with a parentheses around the 5. Okay, so example 3, same process. We're going to simplify first each side of the equation so we can first distribute our 2. So let me just read the inequality out first. We have 2 parentheses y minus 3 and our parentheses plus 8. This is strictly less than 4y plus 10. So let's distribute that 2 inside the parentheses. So we would get 2y minus 6. So outside of our parentheses, we have plus 8y is less than 4y plus 10. Combine like terms. On the one side, we have 2y plus 8y is 10y. Minus 6 is less than 4y plus 10. Get all the y's to one side, all the constants together. So let's subtract 4y. So 10y minus 4y, that's 6y. And let's add 6 to both sides. So 10 plus 6, so this would be less than 16. I'm dividing both sides by 6. So y is less than 16/6, which reduces. Both have 2 in common, so this would be 8/3. So interval notation, negative infinity to 8/3 parentheses. Graph, find 8/3. And we're shading everything to the left in a bracket. So the next one, we have fractions in it, and just like we solved equations with fractions, it's nice to clear those fractions if possible. And so we want to find the LCD. Our inequality, we have x minus 4, that quantity x minus 4 is all over 3. And then plus, outside of that for parentheses, 3 is less than or equal to x over 8. And so if I look at this, my least common denominator of 3 and 8, my LCD is equal to 24. So I want to multiply this side by 24, left-hand side and the right-hand side. So I'm going to multiply each grouping on the left-hand side by 24. So I have 24 times parentheses x minus 4 over 3. Plus, I have 24 times the 3 is less than or equal to 24 times the right-hand side, which is x over 8. And so we chose numbers that would cancel things out. 3 goes into 24 evenly. It goes in 8 times. So let's just distribute this 8 and bring it down. So 8 times the parentheses x minus 4 gives us 8x minus 32 plus 24 times 3, that's 72, is less than or equal to, again, we chose a number for our LCD that would get rid of our denominators. 8 goes into 24 evenly, and it goes 3 times. So we're less than or equal to, we're left with 3x. So let's combine like terms. I have 8x, I have a negative 32 plus 72. So that's plus 40 is less than or equal to 3x. So let's subtract 8x on both sides. We get 40 is less than or equal to, well, 3x minus 8x is negative 5x. I'm going to divide or multiply by a negative number. So I'm going to have to flip this sign. So 40 divided by -5 gives me -8 is greater than or equal to x. Again, it looks better if x is on the left-hand side, so same thing as x is less than or equal to -8. So we have -infinity to -8. We'll shade everything to the left of -8 with the parentheses around -8.
I had a question about taking notes during the lectures.
Yeah.
So if I have to ever leave early during a Zoom meeting, do I just take these notes that you're writing and then I would just take a picture of them and email them to you? Is that how that works?
Yes.
Okay.
Yeah, definitely.
Perfect. Thank you.
So the next example that we're looking at is called a compound inequality. So this is an inequality where we have more than one inequality. And so we have this sandwiched kind of piece inside in between. So there's a couple ways to do this. One way to do it is just keep it like it is. And the only time we can do that is if our variable is just stuck in the middle and, of the terms of those inequalities, and there's not variables on each side. If there was variables on more than just in between, then we would have to rewrite it. So technically, I could rewrite this. This is the same thing as saying -3 is less than -4x plus 1. And, or the intersection of those two sets, what they share in common, and -4x plus 1 has to be less than 17. So what the two sets share in common. Okay. So in this case, because we only have the variable in between the inequalities, we can just leave it like that. Whatever we do to the middle, we got to do on both sides. And so we want to isolate the x in the middle, and we can do that by getting rid of the +1 by subtracting 1 on every side of our inequality. And so we have -3 minus 1, so -4 is less than -4x, which is less than 17 minus 1 is 6. So now we need to get x by itself. We have to divide by -4. The thing is, we're dividing by a negative. So that's going to be changing the direction of my signs. So I'm -4 divided by -4. That's going to be 1 is now greater than my x value, which is now greater than or 16 divided by -4. That gives me -4. Okay, so to me, it makes more sense to go from smallest to largest. So let's flip this around. This is saying that -4 is less than x is less than 1. So we're looking at all the solutions between x equals -4 and x equals 1. So solution would be all x values in between, but not including -4 and 1. So shade them in that region. So the next example, we're given that 5 minus 2x, that's all in parentheses, is raised to the -1 power, is less than or equal to 7. So there's a couple ways that we could approach this. We can use that fact that we had just talked about with reciprocals. If we take the reciprocal, that changes the direction of our inequality. So we could use that fact, or we can rewrite that as a fraction, remember, if we raise something to a negative exponent, we can rewrite that as 1 over whatever we are raising to that negative exponent. So in this case, 1 is all over 5 minus 2x, which is less than or equal to 7. So we could clear our fraction, right? We could multiply both sides by our LCD, 5 minus 2x. And so this would give me 1 is less than or equal to, let's distribute that 7 inside the parentheses. So 7 times 5, so that's 35, minus 7 times 2x, so minus 14x. Constants on one side, so let's subtract 35 on both sides. So 1 minus 35 is negative 34, is less than or equal to negative 14x. Again, we're going to be dividing by a negative, so we want to be careful. We're flipping our sign. Dividing two negatives is a positive, so I have a negative 34 over a negative 14. Let's reduce that. They both have a 2 in common. 2 goes into 34 17 times, and 2 goes into 14 7 times. So 17 sevenths is greater than or equal to x, or x is less than or equal to 17 sevenths. So shading everything to the left of 17 sevenths plus 17 sevenths, so put a bracket on the 17 sevenths. Interval notation, if I wanted to do set builder notation, I have the set x vertical line such that x has to be smaller or less than or equal to 17 sevenths. So next case. This one I saw in the book and I really liked it because this is something similar that we're going to be doing in calculus this week or next week, where we're trying to manipulate inequalities to look like what we want them to look like. And so in this case here, we have if 2 is less than or equal to x is less than 10, then a has to be less than 2x minus 1 is less than b. And we want to figure out what a has and b have to be in that case to make that true. So what we're trying to do, our whole goal, is to manipulate this center here, this x, to look like this center here, this 2x minus 1. So we got to think about order. What would we do to this x to make it look like 2x minus 1? If I subtracted 1 first and then multiplied by 2, then that 1 would inside between would become a 2. So let's first multiply everything in this inequality. 2 is less than x is less than 10. Let's multiply everything through by a 2 to get a 2 here. So 2 times the left-hand side of the inequality is 4 is less than 2 times the x in between is 2x is less than 2 times 10, which is 20. So I'm almost there. The only thing that's different now is that we have this minus 1 out here. And so if we subtract 1 on each side of our inequality, we have 4 minus 1 is 3 is less than 2x minus 1, which is less than 20 minus 1, which is 19. So in order for this to be true, notice that a, that's equal to 3, and b, this is equal to our 19. Okay, so that is in our textbook, the section 1.5. And now we're going to jump into the next section, 1.6, which is absolute value equations and absolute value inequalities.